Now I am going to discuss securing IoT as a chapter 8 of model 4. Here suitably applying the best security practice and perform a formal risk analysis. Here I am going to discuss some of the topics. The presentation as follow: the brief history of operation technology security, and followed by the common challenges in operations technology security, followed by how IT and OT security practices and they vary themselves, and the one more aspect, that is a formal risk analysis structures, especially the model called active and fair, are going to be discussed in detail. Finally, the topic, the phased application of security in an operational environment. So these 5 topics going to be discussed in the subsequent slide. Just follow the history of operation technology security. There are several examples lying in the literature. One such example through the Stuxnet malware. So this creates the physical damage by cyber security attack that damages the uranium enrichment system at Iran. Second one is a furnace in German smelter. So these two physical damages diverting in attention of and it's saying the importance of the security. Lead undesirable outcome from above incident. History of incident report industrial control system ICS. So CERT, that is a cyber emergency response team. So these are the agencies are helping us to bring some information from 2001 to 2015. See, the number of vulnerability reported, that is a industrial control system reported vulnerability started during 2010. So next we have 2011 can see some near 180 vulnerability reported. Subsequently 2012 we can observe some of the vulnerability, more than 200 reports are bring into light. 2013 they are lesser than 200, and 2014 it exceeds the 2012 vulnerability reports, and 2015 can see almost near to 500, approximately 490 something. So these are the vulnerability reported. It says that operation technology system progressed slower than IT. More IT vulnerability reported, but IT are limitedly published. There might be a tremendous reports have noticed related to the IT, but they are not brought into the light. The more towards the vulnerability of operation technology are brought into the light because the IT are frequently happen. OT may not so. So that may be a reason bringing into the light. After history discussion, let we see what are the challenges of challenges in operation technology security. So there are 6 challenges are listed in the literature. So one is a erosion of network architecture, followed by pervasive legacy system, insecure operational protocols, right? So protocol might have some disturbance. So some protocols called Modbus and DNP3 are less secure. ICCP, OPC and IEC protocol. So these are the 6 challenges are listed when you discussing the operation technology. Let me see erosion of network architecture. How it happen erosion of network architecture. So initial design may be wrong, ongoing maintenance may be not proper. So these may be major. And second point, the standard and best practice are not properly understood, may be confused. So now poorly retained. So the second point is a pervasive legacy system. It is a poor utility due to static nature of the machines and long life cycle of equipments. So this could be a pervasive legacy systems going to be hamper. So weakness of equipments are not patched. There earlier the repair or some problems will be there, so that may not repaired. They continued in the old problems, and the problems will be amplified, and the updation will be not so competitive or not enough. Insecure operational protocols. There are some protocols are non-serial based protocol design without inherent strong security request. So that may be reason. For example, SCADA suffers from common security issues, lack of authentication between endpoints. That may be a one operational insecure operational protocol. The Modbus DNP3 protocol are especially for utility, manufacturing unit and transportation system, so on that. So these serial communication between a controller, intelligent electronic devices. So this could be belongs to that distributed network protocol and Modbus protocol. And one more is the ICCP OPC, that is a Inter Control Center Communication Protocol, ICCP, and work across the wireless area network system do not need authentication. So that may also challenge. So OPC is a OLE process control. OPC is a OLE process control, whereas OLE is a object linking and embedding system. So altogether will be OLE process control, that is OPC. So MS Windows product, OPC depends on the RPC, that is a remote procedure calls. Then the one more is called IEC protocol, which is creates a problem. So one such protocol is called MMS. So that is a manufacturing message specification, same as SCADA. The one more is a GOOS. So that is a generic object oriented substation event for measurement and tripping signals. And finally we have SV, that is a sampled value. So this oriented tripping protocol, that sampled value multicast the voltage current on a process bus in a Ethernet. So these are create some challenges to employ the operation technology for IoT. So coming to the device insecurity, the prior 2010 we have seen the Stuxnet malware observation. So prior 2010 the controls trusted on critical system like oil pipelines, transmission systems, some of the very dangerous or the typical systems for that device insecurity may be always a problem. Why system frequently found vulnerable, right? So correlation between the vulnerable black hat Stuxnet. So what correlation will be happening? So before 2010, so community paid less attention to industrial compute as a information technology. Overlaying the count of industrial security via black hat conference with the number of vulnerability reported for industrial control system. So the Black Hat conference held. So there the vulnerability taken into attention. So why the frequently this vulnerability will be appear? Industry control system. So Black Hat and number of vulnerability discovered, so associated showing up discoveries. The correlation between the Black Hat and Stuxnet related to the vulnerability. Easily download the software used and worked against the against them, right? So there is a cheaper softwares are available in the net. You can easily download and have it. So that may also one reason. They operate on a common hardware and standard OS. Example Microsoft. So such systems are there. Windows and components used within those applications. So that may not reliable to the users. Stuxnet is a eminent to identify previously unknown vulnerable in a Windows system. So that could be a one reason. So let me see the correlation of industrial Black Hat presentation with the discovered industrial vulnerability, right? So you can have see 2001 to 2014 and vulnerability report from 0 to 400, right? So let me see. So this plot showing that after the Black Hat conference, so there we have three datas are there. So one data is a Black Hat, and the other one is a Stuxnet malware, and the one more is called the vulnerability, right? So this vulnerability plots we can see that light blue, whereas the strong blue Stuxnet malware indicates the vulnerability in a system. So Black Hat dot is a Black Hat. So these three plots are showing that vulnerability reports. We can see that Stuxnet news is identify the almost all the vulnerability which is previously even they are present in the system but they are unknown. So now they are revealing their existence. So those also will be identified. So that's why we have more than 360 vulnerability observed during 2010, approximately near 2010. So 2009 to 2010 by 2011 is going to be got reduced, that is right. Stuxnet is a very most eminent to identify the previously unknown vulnerability in a Windows system. So finally we can observe that so there is a fluctuation again, it happened 2030 and but the Stuxnet showing the very less for that. So which may be some contradiction between the Black Hat and the Stuxnet news. Anyhow, continuation of this discussion, dependence on external vendors. So obviously today most of the heavy industries or lighter industries depends upon the outsourcing, business operation or storage function to cloud. Thus level of vendor independence is common in some industry, and it is almost true in most of the industry case. So direct and on-demand access to critical system on a plant floor, right? There could be a product warranty, there is a AMC, there is a on-site management, right? So all those aspects will be tells about the dependency of the industry people on the vendors. Vendors remotely manage and monitor the machines, of course. So security knowledge about this IoT. So now in the industry, primarily the connectivity and the compute is a major technical investment. So connectivity they have to be invest. So for which there is a investment is required. Thus less investment for security compared to IT, right? So that major infrastructure is essential for need for investment, but the security purpose there is a hardly investment. For example, 2015, the approximate number of the firewalls used, that is a 4% of the size of the overall firewalls available in the market. So it means that the for security investment is very less. Operation technology security expertise is a higher age of industrial workforce. For example, 2000 to 2012, US labor, the average age gap between manufacturing works and non-manufacturing work is doubled. Education for industry security environment has grown steadily. Training for alertness about hazards. So there are a lot of hands-on training will be for the laborers or workers or the industry people, to make them to aware about the what are the hazards or disturbance will be happening in the industry related to the IoT. Bringing in a bringing an industrial network up to the latest and most secure levels is a slow process due to the deep historical culture and also the beliefs in the society. There is a difference between the operation technology and that is a IoT and information technology environment. So how their practice and system will be varies. So the difference exists between this technology of information and IoT development due to the direct impact on security practices applied to them. There is a impact will be there. So now discussing those here, security threats must be consistently and unequivocally treated. Information technology information used to make a business decision, right? So the business decision is most important for them. So the process, for example, process optimization, operation technology information control physical decisions, right? So for example, increase the pressure or stop the valve, right? So such example will be required physical observation or manual handling. So that will be some problems. Thus operational domain address physical safety and environment factors by inserting a firewall and intruder prevention system in a IoT networks. So operational profile differs between this IT and OT, right? So that's protocol specific and optimized for the IoT. So in that sense, one model called Perdu model for control hierarchy, right? It identifies the levels of operation and defines the each level. So this Perdu model control hierarchy, they have taken 5 levels plus one safety level. So those 5 levels will be put it in a 4 basket. So one is called enterprise zone and that demilitarized zone and operation zone and the process. So this 5 plus 1 safety layer will be adapted to like this. So level 5 is an enterprise zone, that is a corporate level applications are ERP, CRM, documentation, document management and services are addressed here or stored here, and such as an internet access and virtual private network entry from the outside world exist at this level, right? So coming to the level 4, that is a business planning and logistic network, which is again coming in the enterprise zone. So that IT services like scheduling system, material flow application, optimization and planning systems are quite related to business logistics. So local IT related are phone, Gmail and printing, that security check, right? So this level 4 and 5 which are shared by the IT as well as IoT, right? So these are separated by from these below layers called level 0, 1, 2, 3, which are isolated by DMZ, that is a demilitarized zone. So demilitarized zone gives a buffer zone where services and data can shared between operational enterprise zones, right? So operational is a below and enterprise zone is a above, that is a layer 4 and 5. Coming to this demilitarized zone, so let's observe that demilitarized zone. So this public and external resource computing facility, which is protected by the firewalls, which is pictorial on the red walls is act as a firewalls, which are protected from on either side. There is the public network and other is here some company owned systems. Similarly, the demilitarized zone will work between this what is called operational enterprise zone, which will be between SAT. So extension of this demilitarized zone, that is a permit easy segmentation of original control, organization control by default. No traffic should be traverse the in the demilitarized zone. Everything will be start from here or maybe end here. So like it is a military wall, it will be sat between these operational and enterprise zones. Coming to this operational zone, so level 3, the commences that operation and control. So manage the manage workflow to give a desired end product, which will be which will perform by operational control. Security management DHCP, DNS and timing protocols will be there. And level 2, that is a supervisory control. So supervisory control, that is a what we can say that the human machine will be interface here. Human machine will be interface, maybe the industry related aspects. So control room, the status, control system network, and the human machine interface. And coming to the level 1, there is a basic component, so dedicated HMI. So that way other applications may be talk to each other to control function. Level 0 is a basic it's a level 0 is related to the process. So sensors, actuator, devices at ground level, so motors, robots, communication with the control, and all those will be related. Finally we have safety level, that is a device sensor safety control will be installed, so which we have to observe all the monitor all the devices in the secure way, so used to manage the safety function. So this Perdu model for control hierarchy, there are 5 levels including safety and DMZ, that is a demilitarized zone, which is a very the best practice in industry for IoT. So Perdu model for hierarchy, as you can see, logical relation. So that is the enterprise zone, demilitarized zone, the operation zone, and we have process control. So these will be placed one by one. That is a safety critical will be looked after, process level 0, business control level 1, supervisory control level 2, operation control level 3, that is a demilitarized zone, that the information will be shared between the enterprise zone and operation zone. So operation zone, we have the zone called business planning and logistic network level 4, the enterprise network level 5. So enterprise zone and operation zone are separated by the demilitarized zone. So this total levels, the first 5 and 4 levels are common for both IT and IoT, whereas the safety level 0 to level 3 are dedicated to IoT, right? So let me see that. So enterprise zone and operation zones are separated by DMS to protect the firewalls and proxy services and IPS. So IT reside at L4 and L5, and IoT exist at lower levels, plus L4 and L5 are shared between them. So coming to the review associated with industrial security in a 2011 published vulnerability areas. So let's see. So there are components will be PLC, multi-vendor configuration management system, HMI, the historian, data logging, communication, so on, that is. So these are observed 2011 vulnerability report. So let's see that. So PLC is maybe it is one or two we can observe here. So next we can have multi-vendor configuration in the similar fashion as a PLC. So management system is a very huge number of vulnerability reported, that is more than nearly 25, and human machine interface also in the same range. We have historian, the experts are saying about this vulnerability is nearly 5, and data logging of this system vulnerability it is almost 3, and communication maybe less than 2, less than 2. So continuation of this operation technology, new characteristics impacting the security aspects. So let me see, information technology, a common communication data flow from IT endpoints travel relatively far away. So because the network is very big, there are components will be involved, the applications, platform, cloud agents, operating system, CPUs, and all those will be involved in information technology. The data travel far away compared to the OT, right? So operational technology news, that is IoT, L0 to L3, that is a level 0 to level 1, level 2, level 3, two type of operation traffics will be there, can observe. The first one provide the local monitoring and closed loop control used for real-time processing. That is the first one, that operation traffic. We can observe this in the operation technology. We can observe that below the IT, that is a connect, protocol support, protocol conversion, that is IP, maybe IP 4 to IP6 version protocol 4 to 5, 4 to 6, routing protocols, maybe switching, that could be related to that. So coming to the information technology, right, characteristics which impact in the security, frequently traverse the network layers of switches, finally make way to of local or remote server. So coming to this operation technology or IoT, the to control and monitor of overall zones, example SCADA, point-to-point SCADA master to SCADA slaves. So coming to this information technology, data in the form of email, file transfer or print services from the server, right? So that we can observe. So operation technology use a broadcast or multicast concept to send the data. So one such example in the information technology, that email, that endpoint starts and travel around the earth. Similarly, browser, if you open a browser, the from client to that or client to that server, it travel across the globe. The communication in the case of operation technology, the communication could be via TCP or UDP, right? So that observation we have observed. That is coming to the formal risk analysis structure, that is two practices are there in industry, that is active and fair, right? So two such risk assessment framework work towards the established security environment. Two are different method sets of their priorities and knowledge. So this active is a operationally critical threat, assets and vulnerability evaluation. Fair is a factor analysis of information risk. So these two protocols are have a practice. Before going to discuss these protocols, so just we can see some terminologies which may be often used in that the risk analysis structure, right? Asset profile. So what is asset profile? The assets priority, and what is the owner of the who is the custodian, what are the people know about that asset, and what technology are employed over that, and what are the attributes of that asset, right? Also survey and some report on the assets. So those will be asset profile. Coming to the container, asset container. What is the asset container? Range of transport and possible locations where the information reside, or hard copy of the document, or people know about this asset, right? Information, etc. If information is endemic or is a local information, then operate entire container as a whole, right? Not by part, right? So coming to the concern, area of the concern. What is the area of the concern? Depart a data flow and attributes to focus, where decision made through mapping of security based attributes to business focused use cases. Also deal the old risk analysis or comes under the concern of the areas. So next we can identify the scenario that threat scenarios, right? So potential undesirable events, may accidental and malevolent causes or viable threats, right? So that doable threats we can perform, or we can consider that it may be overcome. In operational context, explicit identification of the actors' motivations, outcomes occurs or scenarios, right? So these actors' motivations and outcomes are the scenarios, further assessed with the risk matrix. Coming to the identify risk, possibility of undesired risk will be there in the system. Focus on the how organization impacted extend outside boundaries of operations. Coming to this, analyze the risk, right? Identify the risk and analyze the risk. Effort placed to on qualitative evaluation of impact of the risk. That what quality of risk will be there, how we can reduce them. So in order to reduce that, mitigation approaches. So there are three approaches are in the practice. So one approach is called accept the risk as it is, do nothing, don't say anything about them. Second method is mitigate the risk by walking back through, that is a backtracking concepts we can exercise over them, and we can find the where that risk originated. So that threat scenario by asset profile we can point out that. The third method is defer the decisions, neither accept or nor attempt to mitigate that risk, that is. So these are some vocabularies we have seen. Going to this one by one, this model, that is a active allegro steps and phases. So it is a lightweight and less burdensome process to implement, right? The assumption made by this active allegro that robust security team is not option for operation technology, right? So we need to be secure them. It is not an option like maybe for IT, right? We are treated, it is a compulsory. So right, we have to implement that. We can taken care that how this we have to maintain the secure devices and entire system. Lacking in a security focused human assets, right? So security focused human assets is a most important. So coming to this active allegro system, so the first we have to establish the drivers, maybe ground level sensors, actuators, the devices will be we need to be established. The second one is a profile assets. So profile of the assets we have to see, that is. So third one is identify the threats. So the fourth step is identify them and mitigate the risk. So these four major steps will be taken care to implement the active allegro protocol in order to secure operation technology, IoT. So coming to the first phase called establish the drives. So that is a establish the risk measurement criteria. So there is a set of metrics against which risk can be measured. Maybe fundraising, maybe some the legal points from that respective local body or government, right? So that risk we have to measure, for which certain criteria we need to be exercised. There could be a lot of management criteria are there. So one we have to extend for this. The second aspect is develop the information asset profile. As we see that asset profiles are the owner of the or the document or technology adapted for those profile, the assets and so on. That identify the information asset containers, right? So one container seen in the previous discussion, that is a document related to that assets, right? So there are such several containers will be there. So the fourth step is to identify the areas of concern, that concern we have to take care. So the fifth step is we have to threat scenarios we have to identify and we need to be taken care of them. The step 6 is identify the risk. What are the risks are there, right? Which you have seen in the first step, maybe a fund related to machine, related to legal points, related to environmental aspects. So all those aspects we need to take into care and identify them. Now we have to analyze the risk there. So after analyzing that, the final step is a step 8 called mitigation approach. We need to be mitigate them. There is several practices are there. So how to reduce the those threats, that is. For which the methods we had 3 methods are there. One we have to accept and other one is we have to accept and we have to taken care where it generated and so on, that is, right? So the one more other aspect is a fair, that is a factor analysis of information technology, information risk. It is clear application within a operation technology. Also allow non-malicious actors as a potential cause for harm, right? So emphasis on both the unambiguous definition and ideas that risk and associated attributes are measurable. So definition of risk as the probable frequency and probable magnitude of loss. This frequency and loss are the two definitions will be taken care. So threat event frequency are applied to vulnerability. There are 6 defined forms of loss. They are narrated here, which may be originated 4 externally and 2 internally focused. That is. So coming to the final point, that is final competitive advantages and reputation are the least measurable aspects here in the FAIR protocol. So after observing all this, there is a phase application of security in an operational environment. So we can see that security practices goal to safety secure environment. Operational technology process is different compared to the IT, which can observe this information technology will be receiving inputs, right? And the operation technology will be producing an output which may be a oil, gas, electricity, bandwidth observation, package and water transportation, and all those are the suitable application for the operation technology, right? So for the necessary software will be developed from the information technology. So that will be made the amplification or beautification, and that will be called as operation technology. To protect the priorities and assets, and it is highly differentiated from information technology. Secure network infrastructures and assets we need to be protect in the information technology. So security between the inter-level and zone in the process control hierarchy we have seen in the previous Perdu model of control hierarchy. So that continued discussion here. There is a lower layer that is called process and control, and above that operation, and above that we have a military zone, and above that we have a enterprise zone, right? So we observed that in the previous discussion. So that is a process level 0, just above the safety control there is a basic control, a level 1, and we have a level 2. Level 2 is a area control, right? So we have a what is called a control conduit, that is a IC 6444332 is a RFC. Level 2, which again divided into zone A, zone B, several zones will be there, process. And we have a operations, that is a site operations and control, level 3. And we have a demilitary zone, which is help us to share the resource, that is a enterprise zone and operation zone be separated by demilitary to protect the firewalls and the IPS systems. There in IoT, that is a zone terminal services. And coming to the enterprise zone, that is a site business planning and logistic networks, which you have seen in the Perdu hierarchy model in the previous slide. So that will be a level 4. The top level is a level 5, that is enterprise networks, that is a zone remote systems. So this these are lying as it is. Now we can establish the relation with this because the demilitary zone will help us to source will be generated and terminated there itself. So in that sense, we can have that the RDP, that is a remote desktop protocol will be established to communicate with the above layers, which are enterprise zone to operation zones, will be exchange the information. And we have HTTP will be establish a relation above the demilitary zone to the enterprise zone. So the IT exists at level 4 and 5, and the below levels were dedicated to the IoT. Of course, the level 4 and 5 are shared between IT and IoT, and those are isolated by demilitary zone. Finally, we have the summary. We have so far discussed the history of operation technology security with help of some vulnerability data we have seen with the what is called structured malware and other concepts, and challenges of operation technology, that is we have seen the erosion technology and pervasive legacy system and some DNP and the SCADA practices, then some OPC protocols which will be created, shows some challenges for implementation of the IoT, and the practices of IT and OT security we have seen. And finally, the formal risk analysis structure we have seen, that is Octave and FAIR protocols. And finally, we have phase application of security in a operation technology based on the Perdu model we have discussed in length. So thank you for patient listening and interest on securing IoT. Uh, Thank you.